All right, well, thank you all for being here. My name is Krishna. Can you hear me okay? Yeah, great. And I wanted to share with you a little bit on, how you could efficiently manage your data. A little bit about us. I'm one of the co-founders of Komprise. Komprise is a Silicon Valley company, and this is our third data-related startup. Our last company was acquired by Citrix and did storage for virtual desktops. It eliminated SAN for virtual desktops. So, having been in the data management space for over 18 years now, to us, it's really staggering to see what's happening with storage and data in the last few years. Why? Because data is just growing at such a phenomenal pace now, and it's really breaking out, and it's at a point where data, it's really a tsunami of data coming at us every single day, and this pace is only accelerating. It's shocking to see that 90% of the world's data has been created in the last 2 years. And that trend is accelerating because companies are generating more and more data with mobile cloud and Internet of Things. And often you have to keep that data around for a very long time. So for IT, this is a real challenge. I presume that's why many of you are here at the show, because already 25% of IT budgets are being spent on storage and data management. That's $44 billion a year. And how do you squeeze so much more within that same footprint, because budgets are not growing much, right? So how do you more than double your capacity every 2 years without increasing your budgets? That's a challenge. And that's the challenge that we help companies to address. So when you look at data, one of the problems I think for businesses is it's not only storing the data itself, but it's also all the copies of that data, because you've got to store the data, then you back up, maybe you do weekly backups, then you do monthly backups, probably replicate to another site, and then you archive. So through the life of that data, there's probably at least 3 to 7 copies that you have to keep. So now data is doubling every 2 years, and you have 3 to 7 copies of that data, and so that's the proliferation of that problem. Now imagine if you could, just with the click of a button, across all your storage, start eliminating the need to keep all the data on your primary storage, the need to keep all the backups, all the snapshots, all the archives, and only what's hot you keep on your primary footprint. You keep your primary storage and you keep the high SLA backups in your main footprint. And imagine if the rest of it could transparently be moved into either an object storage on-premise or some cheaper storage on-premise, or into the cloud, or to multiple storage of your choice, and it's all transparent. All the users and applications continue to hit your primary storage. To them, nothing has changed. It looks like everything is there, so nobody has to get worried about any file getting moved or deleted or anything like that. They see everything, but behind the scenes, you've significantly lowered the cost and increased the efficiency of managing the data, because 60 to 90% of that data that is inactive is not consuming the expensive resources anymore. It's being kept in something that's far more efficient, and it's being managed for you. That footprint is continuously being backed up and replicated and everything done on the cheaper storage. That's essentially what we do. We do data-aware management through software. It's just a piece of software it's a virtual machine that you put on premise, you point it at all your data stores. It identifies how your data is growing, how fast it's growing, who's using it, lets you set objectives, and then it manages that data across your storage. So it's not a new silo. It doesn't add any storage footprint. It doesn't require an appliance or anything like that. It just runs as software. It doesn't consume active resources. It runs in the background. So it's designed to be adaptive. So as the file system gets active, it slows down. As your network gets active, it slows down. So it's adaptive to be in the background, and it's resilient. It's highly available, so you never have a single point of failure. The system is scale out. So the way the solution works, you download a simple piece of virtual machine, you point it at your data stores, and within minutes you start getting actual analytics on what's happening to your data. You can interactively plan your strategies. And if you're interested, we actually have a live demo at the booth. We can show you, how this works. We're right behind here. You can look for Princess Leia, and you'll see us. And you can actually model what will happen to your footprint. It shows you what will happen over 3 years to your footprint at your current rate of growth if you use these strategies. And you can look at your costs. And then once you like it, if you can activate a plan, it transparently actually moves that data to targets of your choice. So the targets could be cheaper NAS if you want that. It could be object stores if you want that. It could be public clouds if you want that. It could be any of those things. But something that is easier to manage and consumes less resources, is more cost efficient. And all the data is transparently accessed. So users and apps continue to hit your primary store, and they see the data as if it's there. And as we move the data, we can also protect it and provide you resilient access. So the data is always durable. And we don't interfere with the primary I/O path. So the data, the user access can still go through your primary data store. It doesn't have to go through us. We only get called on move data. And it works through standard protocols, so you don't need any proprietary agents, no proprietary interfaces, no stubs. You don't need to put anything into the file systems. It works with standards, works with any cloud storage. It also gives you an NFS interface into object storage. So if you want to move to object, but you have a lot of file-based access, you actually get an object interface to it. It works across all the protocols. But the other thing we've realized in working with customers over the years is not only do you want to increase efficiency of managing data, but ultimately that data has to be useful. You have to get value out of the data. And that's a real struggle today because data is trapped in so many silos. And it's really hard to know what's useful, what's not useful, or what even any of the data is. So the other thing the solution does, this is just showing you how the transparent access works to a moved file. So the files in the red rectangle have been moved, and you see the files are still shown by Windows as an example here, and you can click on it and it gets the file back. But the third thing is accessing those, understanding what's in the files. So the other thing this solution does is gives you a way to actually index all the data, not only the metadata, but also the content. So you can actually search now across your entire file system. So if across all the storage, so you may have data in EMC and NetApp and HP and maybe some in the cloud, and it doesn't matter. You can actually search for content across all of them and create data-defined volumes. So you can create a mountable volume that is not a physical volume, but it's a virtual volume of exactly the data set you want, even though it spans multiple physical data stores. And that's useful because increasingly businesses want to do things like Hadoop analytics on data, but moving data to a data lake is very expensive. And this solution eliminates the need to have to move things to a data lake. It makes it easy to identify data across wherever they may reside and give that as actually a mountable volume to another process. So those are the three key elements, analyzing and understanding data behavior, moving data based on objectives and managing it, and then giving access to data. And the solution, one of the things is the idea of managing data and the idea of analyzing data is not all that new. The ideas have been around for a while. The problem is most of the solutions have had problems with actually working because either the crawling takes too many cycles and it bogs down the system, or they don't work because people could delete stubs and things like that, and then you don't have access to the files, or they were not cost efficient, they were just too expensive, so the cost of the solution outweighed its effectiveness. This solution has been designed to eliminate all those issues. So it's highly efficient in how it analyzes data. It's designed to be adaptive and run in the background, and it's designed to scale out. It doesn't scale up, it scales out. So we have customers with petabytes of data, and within 5 minutes, we can give them actual analytics on what's happening in their data. And within about 20 minutes, you have a pretty accurate picture of everything because of the way we do it. We use sampling of the data sets to actually create an analysis. And the solution is designed to be scale out. So you can start small, and as data grows, you can add more virtual machines on the fly. And those virtual machines work together as one grid. So you manage it as one, but the system is actually highly available. So there's no single point of failure anywhere in the system. If a virtual machine fails, another virtual machine picks up the slack. If you delete any targets, the system repopulates them. So the entire solution is designed to be fail-safe, scale out, adaptive, and very cost efficient. The pricing is also designed so that you can save about 80 to 85% of costs from just implementing the product. It's designed to give you an immediate ROI. Because those are some of the challenges customers have faced in this market that we're addressing. That's the solution in a nutshell. I know there's some people that just came into the room. Maybe I'll pause a bit. I'd like to see if there's any questions or any comments, any feedback. Yes?
How does the software determine how not to be accessed to a different location? Because sometimes I think that if you put the backup software, backup reading the files every day once a week, how does it know that in the backup process or real user access the data?
Okay, the question is, how do we know when a file has been accessed? Because there are things like backup processes, antivirus scans is another example of something that would continuously be reading files. How do you know that that is not a real read? So our solution actually handles those. It knows when backup software is reading it or antivirus scans are reading, those kinds of processes that read the file system, we actually exclude from the access. The other common problem is many times access times are not set, especially in Windows file servers. You could turn off keeping access times. And the system actually knows to adapt to that as well. It's an adaptive solution. So it actually, if there are no access times present, it actually simulates access times, and then it correlates that with actual behavior. So it'll get smarter and smarter as it gets used because it's adaptive. It's actually watching and learning from your environment. That's how it's designed.
When the file is moved to a different location and you move the pointer on the system, if the user open the pointer during black box, it goes open from the
Okay, another great question. The question was, once a file is moved, if the user opens that file, do we bring the file back? So what we do is, when a file is moved, when the user clicks on that file, we get called. And at that point, we actually have a cache, or we cache the file in our virtual machine and give it back to the user. And then if by the time the file gets to move out of the cache, if more requests have come in for that file, then we know the file is hot, so we write it back. So it's, again, adaptive. So it won't bring it back right away unless you want it that way, because especially if you move to the cloud, you don't want to bring back things too often. So it optimizes that as well. It minimizes the network transfer back from a cloud. Yeah. Great questions. Other questions? Is data growth, I would love to just get a show of hands. Is the growth of data an issue that you're seeing? Roughly how much would you say? Is it like 15% every year or much more? Yeah. 20-25% a year? Yeah. 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 And how about the use of the cloud? Are many people here looking at the cloud? No, it's all on premise. Yeah. Yeah, mostly on premise. Yeah. And how about, are you looking at different classes of storage, like all flash for performance and then maybe cheaper NAS or object stores? Are you looking at kind of segmenting your storage?
Actually, we're looking at a hybrid.
You're looking at hybrid? Yes, yes, yeah.
We have our own all disk array that we are keeping for just storage purposes.
Yep.
Potential backup to it, and we currently have a hybrid with perhaps a nimble storage.
Oh, nimble, okay.
That's performance is nimble. Having the P2 for the
Yeah. Yeah, that's another use case where if you want to use something like all flash for performance, and then you want to have disk-based storage for capacity, you want to make sure that the all flash array is not filled with cold data because that just slows down the performance. So a solution like this actually helps identify and move that out. So your performance actually will improve on the primary system. Okay, unless there are more questions, that's my presentation. And I want to thank you very much. Thank you for being here.